Hello, this is Professor Dina, and I am going to show you about the different types of transformations that are common in elementary school. A lot of these, what are called rigid motions or transformations, are found on standardized tests, and so I'll go through a couple examples of each. We'll start with the most basic, which is a translation. In each of these types of motion, after we take a given shape and we move it, it should still keep the same integrity. It should still be the same size with the corresponding angles being the same measurement, and then also the corresponding sides being the same length. So it's not like we've shrunken or stretched or anything. The original shape, we keep it just like it was before we moved it. So a translation is just going to move something in a particular direction. We'll start with the most basic. Let's just start with moving something 6 units to the right. And we'll start with a triangle. Let's start with a triangle. I'll draw it like this. And I'm going to label, I'm going to label each of the vertices so we can see where it's moved. Let's call this one C, let's call this one A, and we'll call this one B. So what I'm going to do is go to each of the points that are given here, and I'm just going to count 6 tick marks to the right. So starting at point A, I'll go 1, 2, 3, 4, 5. The new point A, or A prime, showing that it's been moved, is going to be there. Similarly with point C, I'll count off 1, 2, 3, 4, 5. The new point C, or C prime, is going to be here. And then for B, we're counting off 1, 2, 3, 4, 5, 6. It looks like point B, 2, 3, is going to be here. We'll call that B prime. Let me draw my new triangle. And B prime is there. So that's been translated 6 units, and we can sometimes draw this in this way, where there's a vector showing the direction of the motion, and we can see that the length of this vector is 6 units, right? So 6 units long. That's an idea that we'll keep if we have a translation that goes in a different direction, not right, left, or up, down, but is following a particular vector. So let's do a second example. I'll draw another triangle. And I'll label it again, B, A, C. And this time what I'm going to do is I'm going to move this triangle in a direction. I'm going to move this triangle along a vector like this. So I need to figure out how many units that has been moved up and how many units it's been moved to the right. So I'm going to draw a triangle here to kind of figure this out. It looks like it's gone 4 units up, and it's gone, 1, 2, 3, 4, 5, 6, 7 units to the right. So what I'm going to do is I'm going to take each of these points, move them up by 4, and then also to the right by 7. So this point A is going to go 4 up, 7 over. So let's see, I went 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, and that's my new point A prime. I'll do the same thing again with point C. I'm going to move up by 4, 1, 2, 3, 4, and then over 7, 1, 2, 3, 4, 5, 6, 7. The new point C is going to be there. Oops, I just lost it here. And I'll call that C prime. And then for point B, I'll do the same thing. Let's go up by 4. 1, 2, 3, 4 over 7. 1, 2, 3, 4, 5, 6, 7. So my new point B is here. Let's call that B prime. And then I'll draw my triangle. And it's been translated according to this vector here, going in that same direction. All right, the next type of motions that we'll look at are reflections. When we have a reflection, there's typically a line that we are reflecting across. So let's look at a reflection. So I'll start again with a new triangle. And we'll label it B, A, C. And I'm going to draw a line that this is going to be reflected across. I'm going to draw a line like this. Now, one of the things that happens in a reflection is that the distance between a particular point and the line is going to be the same as its reflection. So this is a length of 8. So if I go 8 in the other direction, here is where C prime is going to be. And notice that that line is going to meet perpendicularly with the line of reflection. Similarly, point A is going to be 8 away, and then we'll go 8 in this direction as well. So point A prime is going to be here. Oops, that's too far. A little bit too far. Right here, right? A prime. Now point B, let's see how far that is. It looks like it's 8, and then we've got 1, 2, 3, 4, 5, 6, 7. It looks like this length here is going to be 15. So I'm going to count off another 7 going in the other direction. So here is point B. Oops, hang on. Lost my color. Oh, I switched colors. Hang on. 1, 2, 3, 4, 5, 6, 7 here. Is point B prime. So here is my reflected triangle across that line, that black line that's drawn in the center. Now, what if I have a line that's drawn not straight up and down or left, right? What if it's drawn in a different location? Let's do a second example here for reflection. I'm going to draw a smaller triangle here. And again, I'll label it B, A, and C. And suppose that I have a line. Let me actually draw a line with this. I'm going to draw a line like this. And I want to reflect each of these points across the line. So what I'm going to do is think about drawing a perpendicular line between each point. I'm going to erase the point, the letter C, just for a second so I can draw what's going to happen. I am going to go perpendicularly like this. And it looks like I'm going about 2 and a little bit more of a square. So I'm going to go about that same distance. These two distances would be the same, right? This distance will be the same as this distance, and that point here will be the new reflection point. This is point C. This will be point C prime. Similarly, I'll make a line here that's perpendicular to the line of reflection. This length is going to be the same as this length. And so I'll have point A approximately here, or A prime, the new reflection point. And then for our last point, which would be point B, we're going to go like this. This length is going to be the same as this length. Probably a little too long. Typically, when we do this in class, we would have a ruler that we would be using to get all of these points. This will be B prime, this will be C prime. And this is what the part that's sort of missing from our class is we would do this on paper using a ruler and make sure that these measurements are very accurate. But this is the general idea of what you would end up with. And you've got a triangle that's been reflected across the opposite side. Notice that the location of the points A and B are now on the opposite side of the line that we reflected across. Okay, our next set of problems are rotations. And I'm going to do a couple of these. And I'll start by doing a rotation that is with a given axis system. Most of the ones that you come across in elementary school will already have the axis system given to the students. They'll have an X and a Y axis drawn, even though they aren't called that for the students. That just sort of orients like where the drawing is for them. And let's start with a triangle over here. I'll just draw something like this. And suppose I want to rotate this clockwise 90 degrees. All right. Now, the thing that's sort of interesting about this is that what we're doing is we're counting sort of from that origin how many spaces we're going over to the left and how many spaces we're going up. And then we're going to switch that. So what's going to happen is we can see that it's probably going to end up that the triangle looks like this, right? That the hypotenuse, I don't know why it switched my triangle, but the flat side is going to come down, the short side is going to be going up, and the hypotenuse is going to be going across the top after we rotate. I think I can actually, can I rotate this? I think I can rotate this 90 degrees. Oh, it's not going to keep my original. Let me go back. Let me copy. I'm going to paste, and then I'm going to rotate. Let's rotate it 90 degrees this way. And then where would the placement be of this? Well, notice that it was going 3 units over this way and then 2 units up. So those items are going to switch with one another. We're going to have 2 units to the right and 3 units up. So it'll be like this. So notice that I went left by 3 units. Now I'm going up by 3 units. I went up by 2 units. Now I'm going right by 2 units. Let's look at a different point. Let's look at this point up here. This point was to the right of the origin by 3 and was up 1, 2, 3, 4, 5, 6, 8. The point that corresponds, which is here, is going to be right 8 from the origin and up 3. So the those X and Y, what we know as the X and the Y intercepts are interchanging with one another when we make a rotation. What if I were to rotate by 180 degrees? If I were to rotate by 180 degrees, X and Y are going to interchange completely. So let's copy this again. I'm going to rotate it another 90 degrees, so it's going to turn completely upside down. Now, here, instead of being to the left 3, I'm going to be to the right 3. So again, this point here was left 3, up 2. This point here, which corresponds, is right 3 and down 2. When I go 180 degrees, everything just switches, interchanges. Right becomes left, left becomes right, up and down switch with one another. Now, what do we do? There are a couple examples like this on the classwork where you're being asked to rotate about a point and an axis isn't given to you. So for example, suppose that you have some shape. One of them is like a pentagon or something, and it tells you to rotate about this point. It gives you a random point somewhere. Well, if it says, let's say we're going to rotate 90 degrees this way, what you can do is you can just create your own axis system like this, and then follow those same rules, figuring out this distance here and this distance here, and then interchanging it to move it into this quadrant. So you can just make your own axis system as you need to. The interesting thing in elementary school is some kids are really good at doing this in their head by just visualizing and seeing how the shapes are going to move. All right, the last set of examples I'm going to show you is what we call a glide reflection. And it's just a combination of taking a translation, sliding it, and then reflecting. And I just want to show you that if I do the glide first and then the reflection, or vice versa, I should get the same thing. So let's start with something. Let's start with like this. And let's suppose that I am going to go 10 units to the right and then reflect. So let's draw a line here of reflection. I'll just draw a line here. Okay. So what I'm going to do is count off each of these points moving to the right by 10. We label these first. We'll call this C, we'll call this A, we'll call this B. And so let's move this. So point C is going to be here. Point A will be here. And then I guess point B will be here. So here's our new triangle that's been slid over to the right. And then if I reflect it, I'll have a point here. This is B prime. This is C prime. This is A prime. And then I'm going to go, let's see, 1, 2, 3, 4, 5, 6. Just drawing the reflection here, which is going to be like this. Right? So this is a double prime because it's the second movement. This is B double prime and this is C double prime. Now, what I want to show you is that if I had instead done the reflection first, which would have ended up here, 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 right? If I had reflected first and gotten this green triangle and then translated by 10 units, I would have ended up in the same thing. So the only thing I want you to gather from this is that you have a glide and a reflection. You can do the two motions in either order and you'll end up in the same final location. All right, if you have questions about these, send me an email. Have a great day. Thanks for watching.